of ceremony for this evening's lightning talks. So we had somewhere around 26 submissions. I think we're going to get through maybe 18 if you all are well-behaved lightning talk givers. So I think what we're going to try to do here is set up a timer that will give you a soft warning at 4 minutes and 30 seconds. And we'll have another timer that goes, a much more serious timer that goes off at 5 minutes. Now, the much more serious timer will be your cue, and I'll try to lead you all in this, but I think we should practice first just to make sure that we've got this down. When the 5 minute goes off, you'll see me stand up and start to applause, whether the person is done or not. We're very serious about this 5 minute warning, so everybody can get in. So let's just imagine, beep, 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 everybody applause. Go ahead. There you go. Yeah, rapturous applause for a wonderful lightning talk given. So we will stop short of pulling our cane out and pulling you off stage. We're going to get started here in just a minute. So hang tight. So let me just go ahead and give you the names of the folks that, in theory, will be giving lightning talks. So that's one, John Waba, Adam Bowen, Boshan Soon, Norberto or Tagoza, Scott Riebe. Oh, I'm sure I'm butchering your names. You can beat me up later. Jeff Ching, Silas J. Matson, Rockwell Schrock, Jamin Holmgren, David Shanker, Wandera Nimrod, Kyle Henderson, Watchcheck, Gowronski, Andrew Forward, Stephen McCullough, and Dan Swain. If you did not hear your name there, you are most likely not giving a lightning talk. But if you signed up for one, you should stay around and support. So a couple of announcements. Obviously, you know that you're here at Lightning Talks. If you can't handle any more talks, you're talked out, there is yet another option for you. And that's this wonderful event right here. You can go get your drink on and deal no more with talking heads. But we hope that you'll stick around and stay tuned. We'll get this thing kicked off in just a minute. Gold sponsor Grindr. Shout out to gold sponsor Grindr. You guys go support them. This one is our first talk. So Maud, can you hear us? You guys getting audio back there from him? Zero audio. All right. Please stand by for technical difficulties.
Hi everyone. Hi, my name is Makbul and I'm from New Delhi, India. And I'm super excited about Elixir conference. And before I start my talk, I want to thank the volunteers of Elixir conference who made it possible for me to give this lightning talk, and especially the organizer, Dr. Jim Friz. He's a really nice guy who helped me a lot while I was emailing him about. So Lambda calculation, some funny looking character. So this character is used to represent the numeral 5 in Hindi, and I am at McBullism on Twitter. So, starting with this brilliant mathematician Alonzo Church, he's the guy behind the idea of lambda calculus, which is the theoretical foundation for functional programming languages like Elixir, Erlang, or Haskell ML. And he also was the one of the PhD advisor of very famous guy, famous computer scientist. I mean Alan Turing. I mean this Alan Turing. Uh, so these guys has proposed this Church-Turing thesis, which is exactly the main ideas are this. In 1936, they have like come up with a like people was wanted to formalize the definition of algorithms. So when they Alan Church used its lambda calculus to define the what's algorithm says and try to formalize using this notion of using lambda calculus. And Alan Turing used its Turing machine to define the algorithms, which is we all know the algorithm as informal as a step-by-step instruction, but we here try to formalize it. And it turns out that from this thesis that both of those ideas and both of those abstract models are equivalent. And let's look at the syntax of the lambda calculus. It's a variable is a lambda expression, or in which we use uppercase letters for variables like a, b, z, x, whatever you can use for a as a variable, and and m are the lambda expression. Then so each of the following, uh, it's a lambda expression. You use parentheses to say, and then use the lambda abstraction operator, and then pass our formal parameter id here, and our the m is the body, and we then apply the n on m. In this case, where application, we applying the lambda calculus in it. Let's look at the abstract syntax tree of this particular lambda expression, lambda 3. So in this abstract syntax tree, there is an application operator here, apply, and this abstraction operator called lambda. On the left-hand side of this, of the lambda, it's the formal parameter, and in the application side of the it's 3 that which is actually a argument to this lambda, and it got applied, so it's transformed into something like this, and you can think of it's going to be calculated as 4. So uh, using this lambda calculus, you can define pretty much programming languages like logical operators. So logical operators could be defined something like lambda, which takes 2 arguments a and b and returns the first one. For false case, take the 2 argument again, and similarly you can verify that it actually works. It's the attendee's homework, and for the and operator, it's take, and similarly it's returns, and the same is the case with the or operators. Similarly, you can use this also to something called the church numerals or numbers to represent. So 1 is represented by this lambda expression, and 2 and 3 and so on. And this beautiful piece of art of mathematics is a Y Combinator, which allow us to have a recursion in a languages which doesn't have a natively support for the recursion. So these are the resources which I have used to learn about. I've been learning about for 2 days straight. And so here I want to talk a little bit about my Elixir Delhi community, which I'm building with my friend here in New Delhi. So these are the links you might be interested in. And the second link with t-me Elixir Delhi is our Telegram group, where we local people communicate about and learn more about like Elixir related tech. So thank you. That's all my talk.
All right. So you guys really, that's a real special talk there that we just heard. Mode wanted to be here with us today, but he had some visa issues, and so he got up especially early for New Delhi. I think it's about 5 a.m. there right now. So really appreciate that, Mode, again. Next talk, we have one John Waba. John, you here? Give him a round of applause as he makes his way up. What's that? Who signed up again? Oh, after that, we've got Adam Bowen.
Cool. All right, awesome. I want to talk about something very, very evil. Let's do some very bad macros, shall we? Exciting, right? So imagine you're writing a program, and you're running into a problem where it's running a little slowly, and you don't want to have to optimize it. So imagine if you could wrap every single expression in your functions with a read-through cache. Now just hold on for a second here, because I know this sounds evil, but really it works. So let's write some embarrassingly parallel code. Right here we have Fibonacci, the usual, and we're gonna bigger. That good? Awesome. So we're gonna inspect IO inspect 1 twice in it, and using the function def on steroids, because I figured, give your code some steroids. We can jump into this. Bigger. That better? Awesome. And we can jump into this and run test.fib10, and bam, it prints 1 once. Why did it do that? That's because I used the AST as the key for the code and only executed IO inspect 1 once. What happens if I start doing something, expensive, like, say, I don't know, 10,000, right? Make my computer purr for a second and then print it out. Pretty quick, right? Do it one more time? No time at all. That's the magic of caching. Please do not use this in production. So the basic code, as you can tell, is pretty simple. All we do is we call Memoize on the body of the function when we rip out the body and override what we're supposed to be doing. And then whenever we have an operation, instead of actually calling the operation, what we do is we get or store in concache, a really cool library that lets you do this thing. But among other things, it gives you a read-through cache, which is really cool. So then we unquote the body inside as the function callback, and voila, we have memoization. Thank you, everyone.
Serious extra bonus points. 2 minutes to spare on that one. So for the speakers, your 4:30, your soft warning will be directly here in front of you.
Oh, is that my second screen?
So the next talk is going to be Boishan. There you are. Okay, nice.
I guess I can try putting it over there. There we go. Yeah. That's gonna be
Everybody
really
give
hard.
Adam a round of applause.
Let's full screen it, maybe. Okay, that is very zoomed in. Okay, so in the line of doing bad things, I'm going to be talking about using and abusing Ecto. My name is Adam Bowen. I work at EJ4 LLC. That's my Twitter handle. Just as a warning, the following may be a very bad idea. So imagine that we have a third-party defined JSON API specification for works of art. And I say third party so that you don't tell me that the way to solve this is to change how the JSON is structured. I can't. So credit where credit's due. I was inspired to change my example domain by Darren Wilson's talk today. So led to lots of frantic re-editing of my thing. So the JSON API structure, the data structures are well-defined but highly variable. So we're going to store that data in Postgres with JSONB. And so basically, a simple version of it is that we have a work of art which has a type, which defines its possible keys. All works of art have an artist. For example, an album may have a solo artist, or it may have a band composed of artists under a nested artist key. So examples of partial JSON documents to amazing works of art. Animal by Kesha and Love This Giant by David Byrne and St. Vincent. And that's also a really bad example of a band, because their name is like their names with and in the middle of it, but I did this today. So pattern matching in Elixir works great for this. We can break down validation into small parts. We can enforce more global rules and mess with headers and all that sort of stuff without having to drop down into Ecto quite yet. The change sets in Ecto make a lot of individual data structure work pretty easy. So this sort of helps me organize the validation rules into pipelines and provide great error messages. Embedded schemas allow us to validate different data types while keeping the structure in a single JSONB column. And using embeds one and embeds many, I can sort of nest different structures within the data. So the basic schemas we have so far are, we have our work of art module with works of art as the table, and I sort of snipped the rest of this out, but we're embedding one data, which is the art data, which has a title, and then embeds one artist, which is a creator, and then the embedded creator, wait, I'm not sure that we can represent this with how Ecto usually does things, so, because we have multiple different types that can go into this embedded schema. So, what I want is some way to have two different schemas that can possibly fit into this one embeds embeds one column. And so an example would be an artist that just has a name, or we have a band which has a name and then it embeds many artists. And unfortunately, it doesn't support polymorphic embedding. So like most problems in Elixir, I tried to pattern match my way out of this, but unfortunately you can't just like say that you're embedding many and then just give it a generic module and then try to pattern match in that and then do embedded schemas on those things. So then I discovered Ecto type and saw a path through. So if you're not familiar, you basically have to implement 4 callbacks to do an Ecto type properly. So for example, you have type, cast, load, and dump. The important one is going to be cast. So the solution's kind of gross, but we're doing some pattern matching. We're detecting if we're an artist or a band, and then we're casting to a change set down here. And so now we have this solution. We do a field that is a type of creator, and now we can embed both of those. I have 30 seconds. Oh no, I have a minute, slightly. So issues is you cannot give a specific error message to the user because when you aren't valid with an Ecto type, it just says is invalid. And so possible alternatives might be using simple map fields and then validating the maps as separate embedded schemas, but that would be probably a lot of janky code also. And another possibility is figuring out how to replace Ecto type with something that can send error messages. I did a quick look into that, and it didn't seem terribly possible or easy. And the other one is convince the Ecto maintainers that adding a new return type to Ecto type is a good idea, which I'm not sure it is. So the conclusion is sometimes we need to build things that our libraries don't support. Sometimes the situation calls for bad ideas and bad code, and sometimes that's okay. And thanks. And let me know if I did something truly terrible, but because I really do want to know. So yeah.
Another lightning talk, just right on the money. You guys are really good.
Okay, I don't have slides today, but just going to show you a QR encoder in Elixir, and it's pretty easy to use. You just put whatever binary data in Unicode you like, and you do the encode, and then you do the render. It will show up like this. Hold on. Let me just make it smaller. And also, but just generating QR code would not be fun. You want to make some drawing on it. So you can put some zero bits here, and then this area will be your drawing pattern, okay? And also you can have some different orientations. So you can have either portrait or horizontal. So if you can use your imagination, you can draw some QR code like this. And this is a QR repo, so you can just scan this QR code and to check out the repo. Yes, that's it. Thank you.
Up next, we got Scott, and then after Scott here, we've got Norberto. You're next.
USB-C, that's
Oh, you need display port. You do not have.
I've got one down there. Hold on.
Everybody give a round of applause to Dongles. Shout out to Dongles, yeah. So maybe, oh, okay. Another round of applause for Scott, come on. There we go.
All right, so I'm Scott Reeb. I work for IBM Watson in Denver. The group I'm with provides natural language processing as a cloud-based service, which means you submit text, HTML, URL, and you get back entities, concepts, relations, sentiment, emotion, and we have some similar recognition functions for image processing. So back in the 2000s at some point, there was an academic paper published about calculating deep neural networks and new techniques for it. And a sort of a serial entrepreneur looked at that and decided that this was going to enable things that had previously been sort of science fiction. And he started a company. And he used C++ for performance. And back then, for a lot of the basic functions, he picked a framework that was new at the time and was being heavily promoted and turned out to be kind of a piece of crap. So we have hundreds of thousands of lines of code. Some are good, some are bad, and it's all tangled up with this thing that, yeah, it's a mess. They also used XML config files to configure loading of modules and routing and so forth, and yeah, they turned it into a programming language that didn't require recompiling. It could be deployed dynamically, and we have hundreds of thousands of lines of that kind of code. It looks kind of like what you see on the left there. And then on the right is one of the first production Elixir programs I wrote, which trolled the directory, parsed the XML, and generated the dependency graph. Be sure to look at the size of the scroll bar. So this was somewhat unmaintainable. In fact, everybody was afraid of touching it. I was hired to figure out how to deal with this, and they didn't tell me when they hired me exactly how afraid people were of touching this. So the plan we came up with a shim. It was basically a lightweight front end that would proxy calls to this thing. That way we could implement some bug fixes right in the shim, patching up broken returns and broken JSONs and stuff. But the main idea was we developed microservices to replace this giant thing. Routing of calls and the assembly of the results can be changed right in Elixir. Well, okay, it wasn't Elixir to begin with. That decision was made later. What you want when you build something like this is you want to be able to parse JSON and look at the values you're interested in, change the values you're interested in, and ignore the rest. Just let it pass through without having to keep synchronization between fancy class definitions between your shim and the rest of the microservices you're calling. C++, Go, Java, everything that's strictly type checked makes this really awkward. You can do it in C++, it's just ugly. Nested variant types from the Boost library, visitor pattern, etc. Ruby, Python, JavaScript, and Elixir all make this really easy to do. And we're somewhat performance sensitive. Not sub-millisecond time response times because we do a lot of calculations on the back end, so we don't do instant responses. But we don't want to add a whole lot of time just for a shim on front. So Ruby and Python don't support adequate concurrency. You can't pay me to write in Node.js. And I looked at Elixir and really liked it. And we did one set of tests that showed a really small increase in latency. It was the magnitude was bigger than we expected. It was in the milliseconds range, several milliseconds, but it was negative. So that was good enough. So what we know about machine learning and natural language processing changes month to month. It's an area of active research. So you literally can't sit down and say what we're going to be doing 3 years from now. So the API kind of evolved into a convoluted thing that had pieces tacked on here and there. And a complete API redesign of what you were looking at before would have been kind of difficult. So currently in Elixir, we decompose this completely redesigned second generation API that's very clean and very nice, transform it into calls. Some of them still go to the monolith, some of them go to new microservices. Then we transform the JSON that comes back, compose it, and return it. And success. I'm at the 5 minutes, but you can see.
Thanks, Scott. You're up, Roberto. All right, so next up we've got Jeff Ching. So get ready, Jeff, wherever you are.
Ready? Okay. Well, thank you. My name is Norberto, and I work at Bunsen. So I'm going to talk now about how to avoid to use a database. Okay, this is the roadmap. I'm going to give you a little context about this and what we did in order to avoid to use a database in a system that we did for a client and the results. So first, the system that we were working this year was a critical piece of software that was in the center. That is a system that needs to validate a lot of invoices, documents with practical, well, all the documents are XMLs, and all the operation of the company depends on this part. It needs to be very efficient, and we need to find a way to do that part very, very fast and reliable. So in Mexico, we have a lot of regulations about electronic invoices, and this year we have a special requirement about how to manage a lot of validations using catalogs. And we have more or less like 7 gigabytes of catalogs that need to be updated almost every day. And we need to find a way to do that very, very fast. So what we did, first we split the system in an umbrella application. And we have a very tiny layer using just the Phoenix app, a Phoenix app. And we have a workflow using an OTP application. And then we define other applications, OTP applications for the validation of the schema, the catalog, the validation of using the catalogs, and the validation for business logic and a lot of calculus and things that you need to do, search inside the XML documents, etc. We define the rules using YAML, and we create a small compiler in order to compile those rules into an internal format. And we define to load all the catalogs in memory at the start when you boot the system. So we evaluate some solutions, for example, using ETS, but was not good in order to load that kind of data in memory and do the search, because most of all the operations are more related to about to do searching inside the catalogs. We also evaluate Nestia, but has more or less the same problems. And React, for us, was like too much in order to resolve the problem. We also try merge index. But the problem, for example, with merge index is that you need, I spend a lot of time creating doing the indexing of all the catalogs. So it takes a lot of time for us, so it was not an option. So Jorge Garrido was one of the guys working in our team, and he creates this library. You can check that in GitHub. That is Erlang binary lightweight search. And believe me, this is really, really awesome. The results. The system is more or less that kind of line of code. And with the system, you can change the user. The final user can change the rules, add rules, everything without us. They can do everything without change the code of the system. You can process almost 600 invoices per second in just one server. The tests that we have, a suite that we have, runs in less than 2 minutes. You can develop and test everything without any external dependency, and you can scale really, really without any restriction. The system boots in just 5 seconds. So, for example, when you deploy the system, you start, and in 5 seconds you have everything in memory, and you can start doing everything. So, if you want to scale horizontally, you can just add more and more instances, and then you can manage all the load that you really want. So, that's the configuration for the server, by the way. With CPUs and just that kind of memory. And, well, that's it.
Thanks, Roberto. Jeff. We're going to try that here in a minute. Silas, are you around? Silas? No? Rockwell? Is you? Cool. What do we need?
Should be good to go. Oh, that's the wrong view. You don't want to see that.
Just a little unmirror there.
Stand by. Mirror. Sorry. Mirroring. Go. All right. No? Is that? All right, I'll put it back. Oh, that's weird. Oh, okay. All right, hi guys, my name's Rockwell Schrock, and I'd like you to join me on a trip back to 1950s America. We had this great little thing in the US called Project Orion, which was a early space development program, which, believe it or not, was a way to propel rockets into space using a series of nuclear bombs exploded behind the spacecraft. Yeah, I didn't make, this is crazy, but it didn't work out. But turns out that every time I use Elixir, it feels like that every time I get to use all the cool features. So let me share a couple of those with you that I've learned over the past year. Let's talk about pipes. IO-inspect, you use it for debugging. Did you know that you can actually pipe your data right through it? So you've got this great pipeline here. If you want to, say, inspect this change set right before the repo operation, bam, just throw it right in the middle. It'll print the inspection value out to the console and pass the value right through it. Really, really handy. Did you know that you can pipe into a case statement? So again, you've got some really long pipeline. You want to do something based on its result. Just bam, just throw it right into the case and do different operations based off of pattern matching. Let's talk about pattern matching. Kernel.match. This is a really, really cool macro that you can use to basically turn a match into a Boolean, like a truthy value. So if you've got some enumerable and you want to filter based off of a pattern, you can use this shorthand to do that. Really, really handy. Do that all the time. Did you know that regular functions can have multiple clauses, but anonymous functions can have multiple clauses as well? Here's just a quick example. You can just use any kind of pattern matching or guard clauses in there. This one I don't use very much, but when I use it, it's really handy. You're familiar with happy path programming? Well, this is sad path programming. It's a logical opposite. So normally with happy path programming, you want all of your statements to execute successfully. Well, sometimes you only want exactly one to execute. So here's an example where you're trying to pull a bunch of different values out of a map, and you want to, as soon as you find the right value, you want to kick out to that else clause and return it. Really good for kind of fuzzy or search applications like that. Enumerables. You might be familiar with the capture operator. This is the ampersand. It's a really shorthand way to represent anonymous functions. So normally when you're doing an enumerable operation like this, you have the, the FN end. Well, you can also use this shorthand operation and use the ampersand to represent the positional arguments in there. There's also an even shorter way to do this. If you're, for example, mapping to a string, you can actually just map right to the string. You don't even need those extra parentheses. You can do this with tuples as well. And then if you have an external function, you can use this shorthand to call directly to that function without having to wrap it at all. I'm going to get through as many as I can. enum.into, this is a really, really handy one if you're a library designer where you want to accept keyword lists into your functions, but it's a really kind of a pain to deal with keyword lists. So you can convert them into maps, which are really, really handy for pattern matching. This will convert any type of what's called an enumerable, anything that does the enumerable protocol into a collectible protocol, which is a lot of the data types in Elixir. You You can also use it to provide default values and then sort of override them by whatever's passed in. Let's talk about everybody's favorite web framework. Oh, shoot, hold on. Everybody's favorite web framework. You know you can start an IEX session, interactive Elixir console, and you know you can start a Phoenix server, and probably the most useful thing is to combine these. So you can actually have your Phoenix server running and interact with it in real time, which means you can talk with the gen servers, you can interact with your repo, you know, manipulate everything while your server's running. Do that very, very often. While we're talking about IEX, there's all kinds of cool stuff in there. You can reload and recompile a module at runtime without having to quit your session. You can, if you accidentally put a value out on the console, you can grab it using this v macro. You can get your docs right in IEX. There's all kinds of cool stuff. Just type H, you'll see it all there. I got 15 seconds here. Let's jump to overriding controller actions. I do this on pretty much every Phoenix project that I've done so far, where you can actually, this is explained in the Phoenix controller docs, but you can actually override the default action handlers to pass in whatever arguments you want to provide contextual information. So that's it. I'm out of time. Thanks very much, guys.
Give it up for jamming, everybody.
Hey there, I'm Jamin Holmgren. I'm one of the founders of Infinite Red, and I'm going to be talking about an open source library that we built called Thesis. So what is Thesis? It is a content management system for Phoenix. It is built in Elixir. Front end is in React.js. It's lightweight, it's bolt-on, it works with Ecto, and it has very few dependencies. It's supposed to just stay out of your way. Why would you use Thesis? It does not hijack your development workflow. It's not like WordPress where you have to code in WordPress. You code in Phoenix. It has a nice developer experience. You'll see that in a little bit here. Nice user experience, and we're going to do a little demo. Uh-oh, I heard that. Okay, so first off, you can go here to infinitered/thesis-phoenix, start the repo, follow it if you want. What I've done is I've spun up just a default Phoenix web page here. This is a little bit small, I think. So what happens is you build this beautiful web application, and then the customer comes back and says, hey, we need you to make this editable for us. We need to be able to edit this code that says, welcome to Phoenix. Okay, well, no problem. We have Thesis. So I'm going to go ahead and start doing that. Thesis, we just released 0.2.0, not 9. And so I'm going to quit out of that. Mix, deps, get. And while that's going, actually that's done already. I'm going to jump over to, this is all in the README, so you can kind of see exactly how to do this. We're going to add a really quick call here to Thesis editor, pass in the con. And then we're going to run mix phoenix.server again, just so you can kind of see what it adds. And if I refresh, still going here. Oh, one second here, forgot something. So I'm going to call mix thesis.install. So we include an install script. This will go in and add some migrations because this works with Ecto, like I said. So it will add some migrations. It will also inject some code where you need it, just to make it as simple as possible. Okay, now I do mix ecto.migrate to get those, and then I will be running my Phoenix server. I got ahead of myself a little bit there. All right. And there it is. So I'm going to refresh. And down the bottom right, you can see, ooh, we have something new and shiny. But this is still not editable. So how do we do that? I'm going to jump over here. I've added the thesis editor, but I'm going to jump over to the page. Up here is the Jumbotron. And what you do is you simply add a call to content, pass in the con, as usual. Give it an identifier, welcome. And then we're going to say this is an HTML because you can do other types, images, raw text, things like that. And save, refresh over here. I'm going to edit, and you can see that now this is editable. And you notice that it came in with some default content. That's because we just wrapped the HTML that was already there. Pretty cool. So I'm just going to go here. It gives us a rich text editor. Welcome to Thesis. And we're going to say, this is a live demo. And I hit Publish Changes. If I refresh the page, we're done. We've just implemented a content management system. Don't clap too long. All right, a couple other things. We have a page settings. You can go in there and edit like the title, the description, because that's always the next question. How do I do SEO? And you can also go in there and you can copy the contents of the entire page to the clipboard. You can paste in, let's say you have like a staging server where they did all their content editing. You need to move it to live. You can do that here. You can also, you've got revisions. So if I just come over here and I publish the changes, and I go here, you can see that I have more than one revision. So, and that all comes in the same way that you would export and import. So you can back up really easily. Otherwise, come in and talk to me afterward if you're interested. And there's a lot more to this. It's really cool. It really stays out of your way. Like this was a brand new Phoenix app, so I wasn't like pre-configuring anything. That was all done for you. Thank you.
Cool. So next up, we got David Shanker. David, are you here? Grace us with your presence, young David. No? No, David? How about Wandera Nimrod? Come on up. And then after Wandera is going to be Kyle Henderson. Oh. And then Jeff Ching.
Hello, I'm Wandera Nimrod from ThoughtWorks. I'd like to talk to you about special case test doubles for Elixir. This seems to be the time to talk about weird things and bad things, so bear with me. We'll move right into some code. We have my application, which is an app. It has a function in the module that calls Facebook and takes a profile ID and calls Facebook here using a configured HTTP client. If you haven't read Jose's article on mocks and explicit contracts, please go and read that and then come back, you'll find us. So it calls HTTP client, calls Facebook, gets back a response. It doesn't pipe this response in two cases, but you can do that. And then it returns a JSON profile or it returns an error. So the way you would test that is you'd give it a profile ID, and then you'd call the function, and then you'd expect the return profile to be a dummy profile, which is normal. And the way that works is because I've wired up some support class, and not class, sorry, support module, which is in my test.exs. So basically, when you see, what is it called? When you see me doing that, I'm actually getting that HTTP client from application getenv, and I'm reading that value. So in production, it's the real HTTP client, which is that. In testing, it's the other one. So that's just a primer. So just give me a moment. So that that makes it very easy to test the happy path. But if I want to test the sad path, which is if Facebook returns an error and I want to check that my fetch Facebook profile returns the error details wrapped around with a statement saying failed to fetch profile. Now, because I've already fixed myself here, I cannot switch that. I cannot basically go in and make this method return two different things. So what you end up doing is, don't mind that. What you end up having to do is, in your app, instead of depending on the HTTP client right there, you inject the value in the function so that you can override it when you're writing tests. And in my test, what you see is, this is still the happy path test. But what you see here is I'm calling Facebook profile with a fake client, and that fake client is a normal module, which you define and you sort of give it a normal function, and that function will return error. So both of these tests now work. I believe we can start quickly, and yeah, you can see that both of them work. Now, this is good and good enough, but if I want to ask, did my function call fake client with the right value? Like, did it actually use the right Facebook URL? That is a little bit more difficult. You can use sort of get the message and send it to the process with self and then say assert received, which is, I find, inelegant, and it sort of waters down what the test is supposed to be, which is simple documentation. So I'm going to show you something here. So what I do, instead of defining the mock, module, I use a library called Elixir mock. You have to require an import because of bugs. But you said def mock of, so you're defining a mock based on that other module, and you get back that value, and that value is a module. So basically, you can inject it just the same way you injected the module, and this does not override HTTP poison. So HTTP poison remains as it is. It just creates a module, looks at HTTP poison, looks at its API, creates a new module for you, which you can inject, and then you can do things like assert called and refute called. Just to demonstrate, just to demonstrate to you that those modules are clean, look at this test, which basically says I create a mock and I call it custom client, which is the same thing we did. But then I also create another one, which is just mock of the module. And what this one does is it creates a new mock. So we have two mocks. So you can assert on the new mock that when I call get, although I did not define get in this line, I get nil, yeah. And then on the old mock, I still get the value I expected, and HTTP poison still gives me the right value. So that is it. The library is called Elixir mock, and please, these are party tricks. Do not use mocks everywhere you find a boundary between your code, and just be careful when you use mocks, but when you have to, please do so.
Kyle. Hey, come on up, Kyle. We'll get you next, Jeff.
Okay, my name's Kyle Henderson. This is Buckle Up, making your front end reasonable with BuckleScript. So normally when you're working, your Elixir backend is perfect, just beautiful. And then this is your front end. So we got to find a way to solve this problem. So there are some heroes There's Elm, PureScript, Clojure, and a ton of other random ones. But here I'm going to talk about BuckleScript. So what is BuckleScript? BuckleScript it targets OCaml and Reason and converts them to JavaScript. Reason is a version of OCaml created by Facebook that is JavaScript-like, just so the syntax is easier for people to handle. It's got all the standard good stuff, immutable data, type safety, pattern matching. It's recently got errors that are very similar to Elm's type of errors, the very nice, helpful errors. And it's got very strong tooling because everything that works for OCaml that's been produced over the last 20 years works for OCaml and Reason when they're run with BuckleScript. It also has some really nice things where it can build extremely fast. When compared to TypeScript, it's 10 times as fast for the same amount of file sizes. And the output is like, if you've ever worked with TypeScript, it is extremely readable and almost directly translated from your code. So, and who's using it? So it was created by Bloomberg. It's currently, Reason creates up 25% of the messenger.com. So if you've ever used that, you've used Reason. And Google's V8 for their WebAssembly transpiler, they use BuckleScript. So it's really simple, and I think I need to make this larger. It's just that you just hello world is that simple. And Fibonacci's, you just create a function, pass it in. It's got pattern matching, so you can make a switch. And it's very simple. You just pass it in, and then it rolls out. And the other really nice thing about BuckleScript is its JavaScript interpolation. You can just, if your code does not work and for some reason you can't run it properly, you can just pipe it straight in. And so if you look in the second line, it's just, it just does, you just do bs.raw and you can just hack away in JavaScript and deal with the craziness that is JavaScript until you can write good code. And here are all the basic resources. There is already a binding for Phoenix, so you can actually get type safety when doing Phoenix on the front end. There's a URL for setting up BuckleScript. It's just it's all of the details set up by Bloomberg for how they set up the entire system. And I made a very simple Phoenix setup that'll walk you through. It's 4 steps, and then it runs, and you have it all working. And it just works like this. So this is a Phoenix application. And Christ. So and there you go. And that's all you need to do, and you get BuckleScript running in Phoenix. Cool.
All right, we'll see if we have a little bit more luck this time around. Round of applause for Jeff for the persistence. Found another computer.
Engineer at Google, and you can find me on GitHub and Twitter, although I'm not really on Twitter. So don't have any speaker notes, but we'll just wing it. So the problem, let's say we've built an awesome new API, and we want everyone in the world to use it. So first step is, of course, we're probably going to create our own API client for it. And we're going to write in our favorite language, so probably Elixir for all of us first, right? But then we're going to have a new potential user or customer that's going to use a different language, like C# or Java or something else that you may not have familiarity with. So we've got a couple options for how we can approach this. We can build another client for them, or we can tell them, oh, just go build it yourself. Or maybe there's other options. At Google scale, where we've got hundreds of APIs, it's not really feasible for us to do the first one because we have 100 APIs, 200 APIs times 30 languages. It's just too much work for us to do. And telling them to build a client is not really good business for them. So if there's a third option where maybe we can define our APIs in a nice machine-readable way where we can easily generate API clients, that'd be awesome. So luckily for all of us, there's OpenAPI. It's formerly known as Swagger. OpenAPI is an initiative that's backed by many big companies, Google, Microsoft, IBM, Adobe, a bunch of them. And so what is it? So it's a JSON or YAML spec. It defines requests and responses in a very defined way. And it can also optionally specify authentication. Example, I don't have time for that. So what do you get at from this? Code generation. The community has provided so many different code gen options. There's a repo called Swagger API, Swagger Code Gen. So C++, Dart, Elixir, all the ones that you may not want to write API clients for yourself. There's ones out there in the community already. On the server side, you can also generate server stubs that you can fill out later, kind of as a scaffold if you really want to get started. It also generates documentation. One of the coolest things is a browsable HTML and API Explorer. And so here's an example of it, if it loads. And that one's not going to load. But it's documentation and an API Explorer inline where you can actually test real API requests against the real server, which is pretty awesome. Oops. So how does this affect Elixir, I guess? So not many API providers actually produce Elixir libraries for us. And so it's on us to kind of generate those clients for everybody else to use. So what have I been working on? I've been working on improving the Elixir client generator for OpenAPI, and also converting Google API, our internal API spec, into OpenAPI, and then generating the API clients for it. So as of yesterday, I've published 22 APIs for Google Cloud APIs of our 100+ actual APIs, all with 250-something unique versions. And hopefully within the next 2 weeks, they'll all be available to use. So you can use any Google Cloud API, just any API that Google has in Elixir. Super easy. And yeah, that's it. That's all I got.
You want to go? We got David up next.
Okay. So this is a non-technical talk, mostly about convincing other people who might do things like sign your paycheck to start using OTP and Elixir inside your organization. So this is a thing I call baseball. So I'll tell you a little about baseball. We know a little bit about who this is for, and then give you some pointers on if you find yourself in a hot conversation about why you should be doing this. Don't waste my time. This is maybe a few pointers that will help convince people. So the first step of baseball is you need to be aware of the problem. What is the problem? Well, we want to use some new technology in our organization. Well, why would you do something like that? So the next step after someone is aware that you're trying to do something, you want to build some credibility with them. Convince them of reasons why, convince them of possibilities that they didn't previously think of, or perhaps convince them that you know what you're talking about. The next step is asking for permission. So this is where you're going to try to do small things that aren't necessarily the main thing you want to do. So you're asking for cooperation to maybe explore the idea some more. You're already credible. They think you know what you're talking about. So now you got to do some stuff together to try to build the relationship, so to speak. So after that, then you can try to convince them of what you really want to do. So Maybe you talk to your boss, and your boss says, well, this is a really new thing. I don't believe it's possible. It's not really proven. You say, well, listen, all things have risk. That's okay. And your boss says, oh, yeah, maybe that's a good point. Everything has risk. So you say, why don't we build something small with it, end-to-end, as a prototype, and see how we feel about that. And then your boss might say something really nice, like, yeah, sure, take some time, aside from the regular features you're building, and why don't you try and develop this freely and do what you want to do. Later on, you're maybe talking with the vice president of engineering, and the vice president of engineering says, well, we don't use this in our organization. That's really a non-standard thing. And you say, well, there's complexity of all kinds. We've got teams using all kinds of languages. What I'm really asking for is maybe a little more of a new attitude towards new technologies. So that's kind of a cultural issue in your organization you can try to address as you go up. Then you say, well, listen, here's a thing that I built with my boss's permission. It works really great. We already have it in production. And the VP says, I didn't know about this. And then he goes to your boss, and your boss says, oh, yeah, this got built, and it works great. I hope we have more stuff like this. Later on, someone in the C-suite finds out what's going on, and they're not too happy about it. Oh, there's new things in the organization, new technologies, things that I've never heard of. And you and your boss and the vice president of engineering, and you all get together, you say, listen, well, we need to try some new things. We need to maybe try new languages and maybe increase efforts to use these new languages because we have risks we want to mitigate against. We want to make sure we get top talent. And as you can see from these other previously made projects, it wasn't too risky for us as an organization to do this. And then the CEO says, well, how do we make sure we keep getting talented people to do these nice things? And everybody says, well, let's send them to conferences and let's have them talk to other people working on these projects. And eventually you get your organization doing more community engagement, and everybody's happy, and hopefully Elixir becomes a bigger part of your organization. So that's it. Thank you.
Next up, we've got Vocek. Sweet. So after Vocek here, we've got Andrew Forward. So ready yourself, Andrew.
Okay. Hello, everyone. My name is Wojciech. Some of you may remember me from the debugging and firefighting workshop, when we scratched the surface, and I've shown a little bit of our in-house build tool called XProf. XProf is basically a visual profiler based on Erlang tracing. We built it in-house because we are facing with a big Erlang system that needs to be maintained, extended, and we're obviously having performance issues as well. At the beginning, Michal started work on it, and then 4 of us involved into the project. For those of you who are not familiar with profiling, it's basically a way of instrumenting your application code and trying to narrow down what is the performance issue when it comes to memory, time, and other stuff. Here's the GitHub and HexPM, because we are on the HexPM. Project started as an Erlang only thing, but right now we are fully support Elixir as well when it comes to match specifications and also other stuff. I've got a quick demo on as a video because I don't want to mess up with the guts of the demos. Basically, after you add your dependency into Mix.ixs and start the XProf application, you will be able to access the 7890 port in your browser. And then you will see the UI. In the UI, you will be able to type the match specifications as in the example. So try me module with the nub function RETF2. And you will see timeline. Basically, on the left, you are seeing call time, and on the right, you will see call counts. You will be able to enable particular percentiles, medians, means, and so on. You are also able to show slower calls above certain threshold, and you will be able to expect everything like arguments, bits, and call time. As I said, we are supporting match specs. So basically, we'll be able to do more fancier stuff than just tracing by the module function RET tuple, like in the example which you can see here. So you are able to basically type your own guards, and then based on that, and based on traced, pinpoint real reason what's going wrong. Our typical behavior with how we will use XProf is basically we have monitoring in place or any other customer support. They will complain that something is going really slowly. Then we are jumping into live production system where we use XProf. We graph. We are trying to do outside in. Basically, we are starting from more general stuff and going into inner functions. We are trying comparing stuff between. That's why we build a visual tool for that. We are trying to capture arguments, narrow down with match specification. We modify code, deploy new version, and that's a profit. So yeah, that's everything what I have right now. We need users, and basically, if you would be interested to talk about this or use it, feel free. We are open to pull requests, issues on GitHub, and that's it. Thank you very much.
All right, Andrew, forward. It also looks like we're going to have enough time to get into some of the folks that we didn't think we would be able to. Andrew, are you here? Maybe? No? Okay. How about Steven? Steven McCullough? No? How about Dan? Dan? Everybody's bailed? This is fun. We'll just keep going. How about Kyle Oba? Kyle? Kyle, come on up. Come on. Come on down. Yeah. And then after Kyle, we've got one Zach Barnes. Zach, are you here? Great. Just come on up towards the front, and we'll get rolling. Bear with us for a minute as we get this hooked up.
Is that big enough? Is that big enough? Yes? All right. Hi, everybody. My name is Kyle Oba. I'm from Honolulu, and I'm here to talk to you today about Lisp, or what happens to your project when you think things like, how can I put Lisp everywhere in the front end? Anyway, this is really simple. I mean, this is really similar to the BuckleScript presentation, so I was pretty psyched to see that. Also, how do I advance my slides? That's weird. Okay. In that, yeah, there's a lot of really interesting ways to do the front end these days, and the defaults aren't so awesome. So originally, I just thought, hey, I'm going to try to get Phoenix working with one of the ClojureScript wrappers around React. And I had a surprising amount of issues with that. It's kind of weird. I can't see the whole screen. Let me see. Sorry about that. Try to roll with that. All right, whatever. Ooh, that's not good. Okay, how about that? All right, that's probably good enough. And so I started out with Brunch, then I went to Webpack 1 with ClojureScript, finally got everything working. But then like I closed my eyes for like 5 minutes, I came back, Webpack 2 came out, and I was like, hey, I guess I'm gonna need to spend a few more days learning about Webpack 2. So I got working on Webpack 2, and then Webpack 3 came out, and I said, okay, that's kind of enough. So this is what happens when you like watch a bunch of videos. You like binge watch Joe Armstrong and Rich Hickey videos. You start getting these ideas. Like if you read those, if you watch those videos, you start having these ideas like, why is my front end so complicated, right? And so I started using Boot, which is actually a Clojure build tool. So your build scripts are in Clojure, and it works really well with Hoplon, which is a web framework. It's more of a library, but it's really cool. It actually doesn't use React either. So I've removed Brunch, Webpack, and React from my dependencies, and I feel kind of good about it, actually. And it also uses this library called Javelin, which is sort of like a spreadsheet-like data flow library that handles your state on the front end. And essentially you have cells and you have formulas, right? And the formula cells are dependent on the cells. And it does what you think in an FRP sense. And they're decoupled from the interface, which is pretty cool. So, all right, so cool. There's like these, I'm getting all this stuff working, and I'm thinking, wow, there's a lot of like similarities between what's going on in Elixir and Phoenix communities, where I feel like it's awesome because everyone's very respectful of your time and how easy things are to get going, and not wasting your time on unnecessary churn and all that kind of stuff. And the Hoplon folks are also really very sensitive about total cost of ownership, which is really important to me. Yeah, so not a lot of churn there either. Okay, so what are the benefits of ClojureScript? This is just a couple, or a few. Same notion of equality. Well, that's huge, right? There's namespaces and immutable data by default. I mean, it seems simple, but like you drop down into XYZ, and it's just not so happy. Anyway, and then on the Google Clojure compiler, so folks that don't know, Google Clojure compiler is what's used to turn Lisp into JavaScript, which sounds nuts, but it's pretty cool. So it does this, and it's a Google project that's been open sourced in 2010. It does aggressive renaming of your code, dead code removal, so that whole like tree shaking stuff, it does something better, I believe. I'm not an expert. Anyway, and it does function inlining. And that will include stuff that you put in your project, such as Phoenix.js. Okay, I'm just gonna fly through this. I'm putting together a pull request to get the Phoenix.js 1.3 JavaScript file into the CLJS manager, which is sweet because then you just pull it in, you don't have to do anything. And also you get all the stuff that you normally have that always works. And I've got like a few seconds, so I'm gonna, this is what your build script looks like. This is less than 100 lines. It does everything I needed to do. ClojureScript, CSS, auto-prefixer, post-CSS, reloading, crazy optimizations, and let's see. That's probably a bad idea to try to do this really fast, but I will do it anyway. All right, cool. See that? Okay, cool. So this is like an awesome chat app that you might build in Phoenix, right? So that's all running in ClojureScript. And then also, if I go to the browser REPL, I don't know how many people have browser REPL here, but this is running in Emacs. And what I can do is I can say run a, oh, I'm out of time, but I can run that. And, okay, I got 30 seconds. Sweet. Okay, cool. So basically, from Emacs, I can talk to my browser and update the state of my application and have the UI refresh. And really, it's like one line of code. So I don't know, blah, 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 blah. And I don't know if you saw that update over there, but that's it. That's all I have. And I'm super happy with it.
All right, where's our next speaker? Right? You? Yeah, come on. Appreciate it, Kyle. Zach? So after Zach, we've got Bryn Wankel. Are you here? Wave me down. There you are. Okay. And then Gerald Unruh. Sure, I'm just murdering everybody's names here. I'll get it right one day.
All right, so my name is Zach Barnes. I am a backend developer at Toyota Connected, and I would like you to type spec for the love of God. So what is type specking? Most of you probably already know this, but for a refresher, types are the things that your data can be. So for example, strings, integers, booleans, maybe something more complex such as a list, or maybe more Elixir specific such as a struct or an atom or a user-defined type. So type specking would be the act of specifying the types a function can take and the types it can return. In Elixir, we have a dynamically typed language, meaning that at compile time, Elixir just infers what your types are. So we don't have to tell it what it is, but I'm going to ask you to do that anyway because it's going to have a lot of good things. Why does it matter? It lets you catch errors sooner. Oftentimes, you don't know that something's wrong until your code's already running. At that point, you find that someone had put an integer where it's supposed to be a string and something blows up, and then you have to go call your DevOps guys and fix everything in the middle of the night. If you use type specking, you can run static analysis to figure out what's actually working now and if you're passing the right types around. And the second thing that I want to talk about a lot is better documentation. This is something that we've been dealing with at Toyota Connected. It's good for you and it's good for your teams. We've been growing very, very quickly. And in doing so, we have built a lot of code that's not necessarily documented very well. I know none of you have dealt with that, so don't judge us too much, but we're going back and fixing that right now. And during that process, I stumbled upon some code that I want to show you guys and show you why type specking is valuable. I'm not going to call anybody out, but the author of this code is in the crowd right now, so I'll let you guys try and figure that out. But we're going to look at this together and try and figure out what the heck is happening. We have a function, vehicles preload include all. It's going to preload stuff on the vehicles, I guess, by the name. It takes 4 arguments. The first is vehicles, it's plural, so it's probably a list. Vehicles is a schema type we have, so I'm just going to go with that assumption. We have a since and until. Those are probably dates, but we use ISO timestamps, we use Unix timestamps, and we use a datetime struct, so your guess is as good as mine as to what those actually are. And then include, probably a string because 3 lines later this says string.replace. And then what does this function actually return? Well, I don't know because the last function is load vehicle estimated billing cost. So that means we have to go into that function and do this all over again and try and figure this out. So not only did we just do this, all the developers that come behind me are going to have to do the exact same thing. So now your team is wasting time trying to figure out what exactly is happening. Very, very, very simple solution is to add 1 line, at spec, and then list it all out. The function, you just put the same thing, vehicle preload include all. The first argument is going to be a list of vehicle structs. The second argument is a datetime. The third argument is a datetime. The last argument is a string. The final thing that colon tells you this is what we're going to return. It's going to return a list of vehicle structs. Now, anyone else that follows behind you is going to be able to look at this and say, oh, okay, this is what I'm getting. I know how to use this. This public API makes a lot of sense. They don't have to worry about doing the exact same thing we just did. If you want more information, go check out the type specs at Hexdocs. Those are very good as usual. The Elixir language page has some stuff on getting started. And the obligatory shout out, Toyota Connected is hiring in Texas. We have a booth outside, so come check us out and talk to us.
That's great. Is this mic on? Yeah, there we go. So hi, I'm Brian Wonkel. I'm from Lab 0. We wrote a little tool called Bootleg. And yeah, it's basically what we hope will be a simple way to deploy and automate your Elixir applications. So it's just a simple set of commands. It's a bunch of macros, basically, that define a DSL that you can use to describe how you want your deploy to work. And just to give a basic deploy workflow, you have your code, and then there's the build step where you actually compile it. You use distillery to create a release, and then you deploy it, which will push it out to any number of servers that need to run your application. So what Bootleg does is it sort of handles everything that's wrapped around there. It uses distillery under the hood to actually generate the release. It connects to a remote server to do that build so that you You can have a build server that matches the architecture that you're going to deploy to. That's how you install it. You have to include distillery. Like I said, it uses distillery to actually create the release. That's how you configure it. You define roles. So right now, you would define a build role, which is where it's going to build. You define an app role, which is where the app is going to be deployed to. And that can take either, like you can see here, it's going to take a list of hosts. So it can take one or more hosts. There's some configuration stuff. This is all in the docs. Then you get a bunch of commands. So build, deploy, start. There's stop. There's restart. There's update. And you can customize it too. So like I said, it's a bunch of DSLs, or it's a DSL that a bunch of macros. So you can define tasks to do additional things. If your deploy does more than just build a release and push it out, you could do things like clear logs, start up your Phoenix server. Let's see, and then there's a bunch of hooks. So here we create a little task called clear logs, and we want it to run after the deploy runs. So we define an after task for deploy that will clear the logs when it runs, and you can do a lot more advanced things. We have this macro called remote that you provide a role, and it actually runs whatever commands you define inside there. It will run them on every host that's part of that role. And we're on GitHub, Lab0 Bootleg. It's on Hex. You just include Bootleg. And then we're usually hanging out on the Elixir Lang Slack in either the Bootleg channel or the deployment channel, which is the most active place to find us. We monitor both of those. That's me. If you need to contact me. Yeah, that's all.
Thanks, Brian. Next, we got Gerald. Yeah. And after Gerald, we've got Angel. Jose? Angel, are you here? No? How about Aaron? Renner? Come on up, Aaron. Get ready. Brian Glusman? Brian, are you here? No? How about Daniel Azuma? Okay.
Hello, I'm Gerald. I'm a backend engineer at Toyota Connected, and we're building the mobility services platform. So at Toyota Connected, we're tasked with building products for car sharing and fleet management. And that means we need to solve problems that look like this. And if you deal with tracking locations of objects, you've maybe solved this problem, or you will need to eventually. And that is, how can you be notified when an object you care about enters or exits an area of interest? So the areas of interest are polygons called geofences or zones. And this is simple when there's just a few objects and a few objects and geofences, but what if there's any number of each? Toyota sells about 10 million cars per year, and we're building global software, so we need to plan for significant load. So the simple way is to query a database every time an object moves, but that would generate tremendous load. So instead what we have here is a streaming database that holds a state for each live object, and as that object moves, we run calculations for each time it updates. And then this database emits enter and leave events as it interacts with the geofences. When we run this in a cluster, each node can hold a copy of the geofences, so it can do these calculations locally, and these geofences can be shared with Amnesia. Since each object has its own process, how do we set initial state when a vehicle's process starts? Postgres or other long-term storage. So when an object's process starts, it fetches the last known state for that vehicle or object, whatever you're tracking. And then when that object enters or leaves a geofence, the database can emit an enter or exit event and send it somewhere with PubSub. Or it can periodically save the object state back to long-term storage. So here we have a process that died, and it goes away. And so all the state, anything that you knew about that vehicle is gone. So when it respawns, we pull the last known state from long-term storage, and now we know how to run calculations on it again. We can carry on with live data processing. So what about handling the mathematical load in Elixir? Here's every city block in the borough of Brooklyn, New York, and that's a little over 5,000 geofences. And these red dots represent 10,000 vehicles driving through the city. So I'll show a demo here, and this is what the setup looks like. The top graph is observer, and that's CPU load. And this is running on a 4-core DigitalOcean droplet. And for this example, we have 10,000 vehicles, and each one is updating their location every second. And as they drive through the polygons, the database will emit the enter and exit events. So the first thing that will happen when a node starts is we load all these geofences in using a library named envelope. And that allows very efficient spatial lookups. So I'll start this, if I can find my mouse. There we go. So now it's loading the geofences in. And that causes a little CPU spike when the node starts. And now we're pushing vehicle location updates through, and we're pushing about 10,000 per second. And you can see that processing, it's comparing against 5,000 geofences in about 500 microseconds. And we're stable at about 10,000 updates per second. And that's one node. So then this is using Swarm, and so these processes for the vehicles can be running on any node in the cluster. So when we do a lookup, that can be run on the local node or a different node. So we care a lot about open source at Toyota Connected, and most of the code behind this is open. We're using envelope and topo for sure. And these are all on Hex, so feel free to use them, and you can contribute back to them if you like. We're also hiring, so if this sounds exciting, feel free to talk with one of us, and we have a table outside too. That's it, thanks.
Cool. My name is Aaron Renner. I'm a software engineer at Active Prospect, and recently I've had the opportunity to dive into the Elixir deployment toolchain. So as you're building your app, when you're getting ready to deploy to production for the first time, it's like, how do we deploy it? There's options like, well, we could use Heroku, we could run mixed Phoenix server in production, but what's in the Elixir ecosystem? What are these OTP releases? So Distillery is pretty much the de facto standard for compiling and packaging your application. And the cool thing about this is it packages in an Erlang VM, so you can ship your code out to a clean server and get it started. Pretty straightforward to set up, and there's a guide to how to tweak your Phoenix app to use it with Distillery. Once you generate the release using mixed release, it creates a folder out in build, prod, rel, and then your app name. This folder structure here is what gets shipped out to the server. So anything that's using Distillery, this is what you'll see out on the server. One cool thing is out in bin, there's a script with the name of your app that's the control script for starting and stopping your app. So it can do things like starting your app as a daemon. You can connect in to a remote console for your running app. You can ping it. You can even do hot code upgrades. Pretty neat tool. So once you have this build put together, how do we ship it? One way you can do it is tar it up and SSH it out or SCP it out to a server. Another way you can do it is edeliver, or as we just saw, bootleg. So edeliver builds your application on a remote build server, and the reason this is important is so that the Erlang runtime you're bundling matches or is compiled for the operating system that you're going to run in production. Once it builds it on the remote build server, it deploys it to staging, or you can use it to deploy to staging production. The config file is pretty simple. There's some, you put in your staging host, production host, and it's also a bash script. So if you need to make changes, script some things in here, you can do that as well. So you can you start off running mix edeliver to build your release, and that builds the release on the local build machine, and then copies it to your laptop so you have a compiled release locally. Then you can take that same release, deploy it to staging, and then go ahead and deploy it to production. It also has nice wrappers around those distillery functions where you can start your app across all nodes, ping across all nodes. It's a cool tool. So once we start building the app, or if we build the app and deploy to multiple environments, the tricky part is what do we do with configuration that's different between these environments. For example, staging may have one set of API keys, prod may have another. So what happens when your app is compiled is it takes your config.exs files and compiles them down into a sysconfig file that goes out into, or that's part of your release. Now that sysconfig file, this is small, but it's an Erlang file that gets loaded to build your application environment when you call application.getEnv. So really, instead of checking this in and managing this per environment, you just really want to inject the changes that you want to make, like replacing host names. That's where conform comes in. It allows you to inject those changes. You define a nice app.conf file, and then conform takes that sysconfig, takes the changes from app.conf, and creates a new sysconfig that's used to actually start your application. And that has all of your new changes in. Last thing, 30 seconds. Last thing, if you're doing this, don't compile API keys into module variables because you won't be able to switch them out at runtime. And instead just call application.env. The tools are distillery, edeliver, and conform. They work great. We use it in production. Thank you, and we're hiring.